Okay, can you see my screen? Factor influencing intention to share knowledge in an organization. Okay, so here this paper is trying to understand, investigate or study the intention to share knowledge in an organization. So they have taken a theoretical model first, the theory of planned behavior, the theory of planned behavior, TPB. Okay, it's very popular theory in behavioral study, especially those who want to study the intention of anything. They commonly adopt this, theory. Okay, Mr. Eisen, 1991, who has proposed this, theory. Okay, this is exactly what Mr. Eisen proposed. Okay, attitudes towards behavior, subjective norm, perceived behavioral control, intention, and actual behavior. So in figure 1, they have said this is the theory of planned behavior. So this is the theoretical model. Okay, this is the theoretical model. So now they have brought some changes. Okay, so the changes is like this. They simply remove the behavioral intention. Oh, sorry, actual behavior. Actual behavior, right? Actual behavior from the theoretical model. So that make it a research framework. Okay, a research framework. So now, why? Because they want to study this one. This is their research interest. Okay, they want to study only this. 4 variables. So we see the difference between research framework or research model with the theoretical model. Now, what is conceptual model? Okay, conceptual model is part of this can be also part of your conceptual model. Okay, this is also part of your conceptual model if you do not go further for testing the model. Okay, so you have presented your concept in a framework. So this is my understanding, this is my propositions. You understand? So what you said in the paper, so my propositions should be tested empirically in future to see whether the relationship works or not. So there's the ending of your paper. You haven't tested their their relationship. You didn't go for collecting data. So you just presented the idea from the literature review or from the theoretical, implications. So then you say, oh, this is my, logical, representation of my idea. Internet is very unstable. You understand?
Yes, yes.
Okay. So the same framework, the conceptual framework, after that will be used as a research model or research framework, right? So if we place the consecutively 3 framework in an order, so then the theoretical framework will becomes first. After that, the conceptual model, and after that, there's the research model, right? So that is the logical consequences of my development. Okay. Okay. Now move on to our. So we talk about this model, right? We want to test the cloud computing adoption. So we have data, for this model. Okay. And we want to replicate a paper, but not exactly because we don't have the data. Right, this paper, a consistent PLS, this paper. And now we see a model like this. So the question was, why should we adopt and take theoretical framework? So answer is to justify my relationship. For example, I said perceived useful ease of use has a positive effect on Facebook users. So this is my hypothesis, and the point is whether the hypothesis is logical, rational, or whether or is it, I mean, rational to draw a conclusion like this or to draw a design like this. Okay, so we need to justify each relationship. Okay, for example, the perceived usefulness is a kind of independent variable, and Facebook users is a dependent variable. So is it logical to draw a relationship like this? So to justify each relationships, we need to justify it from theoretical point of view. If not, then previous studies, and if not, we have to justify by placing our arguments logically, rationally, that yes, this relationship makes sense. So that's the conclusion we want to draw. Okay, because sometimes we design a relationship that may be sensical or logical from my understanding, but may not be logical from others, understanding. So that's why we have to, justify the relationships. I think Nazmul Shakib, you have sent me a paper, right? So I guess I have given you similar, suggestions to justify the relationship from theoretical perspectives. Okay, so the idea is they want to test the relationship. Okay, so let's start from the beginning, how they have designed the paper. So there's the abstract. You know how to design the abstract. Okay, there's the introduction and the theory and hypothesis development. So we need to discuss something from this. So although they have not given a title like literature review, but we understand this is talk about literature review and hypothesis development. You will find a very common title in the paper, literature review and hypothesis development. This type of heading is very common in the paper. So they have given theoretical justification first. Okay, then they have operationalized their definitions, variables. For example, what is mean by perceived ease of use? So they have given the description. So the degree to which a person believes that using a particular system would be free from effort. So means it would be very user friendly, for example, user friendly of using Facebook. Okay. So now they have drawn they developed two hypotheses. Perceived ease of use will have a positive effect on perceived enjoyment. Perceived ease of use will have a positive effect on users. Okay, they said, yeah, two hypotheses. Perceived ease of use will have a positive effect on perceived enjoyment. Perceived ease of use will have a positive effect on Facebook users. So they have designed here two hypotheses. Okay, then the second one, right? For this, the similar hypothesis, perceived usefulness will have positive effect on perceived enjoyment and will have positive effect on Facebook users. Let's see. Okay, perceived usefulness means what? The degree to which a person believes that using a particular system would enhance his or her job performance. Okay, this is perceived usefulness. I mean, what are the utilities it will bring to my career or to my job? Okay, there's the kind of belief. What is my understanding? What is my belief? Okay, so again, they have developed here two hypotheses. Perceived usefulness will have a positive effect on perceived enjoyment. Okay, and now perceived enjoyment will have a positive effect on users. What is perceived enjoyment? Perceived enjoyment is defined as the extent to which the activity of using the computer is perceived to be enjoyable in its own right, apart from any performance consequences that may be anticipated. Okay, means it is enjoyable. Okay, so we see very similar constructs. One talk about usefulness, one talk about enjoyment, one talk about easiness. So these three actually lead me to adopt Facebook users. So that's the very simple model and very logical, right? It seems very logical and rational. Okay, now the methodology. For the purpose of this study. Okay, so far, is there any question about the hypothesis development and the model development process? Do you have any question?
Sir, মামুন বলছিলাম স্যার একটা আন্ডারস্ট্যান্ডিং ছিল স্যার এখানে দেখতে পাচ্ছি যে মানে পারসিভ ইজ অফ ইউজ এন্ড পারসিভ এনজয়মেন্ট রিলেশন ঠিক আছে, আবার এখানে কি মিডিয়েটর বা ডিরেক্ট রিলেশন এই দুটাই তো আছে না?
Oh, all right, that's the question. Nice question, I think. Okay, so the question is, we see a kind of mediation. It seems there is a mediation in this model, like perceived enjoyment. We see the connection from perceived ease of use from here to there, and through enjoyment it connect to the Facebook users. So means perceived ease of use is the relationship between perceived ease of use and Facebook users is mediated by perceived enjoyment. Okay, let me repeat the relationship mediation. The relationship between perceived ease of use and Facebook users is mediated by perceived enjoyment. Okay, so again another mediation we see the relationship between perceived usefulness and the Facebook users is mediated, right, by perceived enjoyment. So apparently it seems there is a mediation, and the mediator variable is perceived enjoyment apparently. But sometimes my drawing, has kind of mediation, but if I don't have hypothesis, if I did not develop the hypothesis for the mediation, so I need not to test the mediation. That's the understanding. Okay, because the hypothesis comes from the purpose of my study, from the objective of my study, from the research questions of my study. If there is no purpose to test the mediation, or if there is no research questions related to testing the mediation, so I should not report or I should not present the result of mediation. That's the understanding. Is it clear?
তবে আমার একটু জানার ছিল যে মানে আমার এক্সপেরিয়েন্স থেকে দেখলাম স্যার, যদি কোনো পেপারে রিসার্চ পেপারে যদি মিডিয়েটর বা মডারেটর ইম্প্যাক্ট যদি আমরা যদি শো না করি, সেক্ষেত্রে নর্মাল ইফেক্ট, ডিরেক্ট ইফেক্ট দিয়ে মানে যে কোনো ইয়াতে এটাকে ইন্টারন্যাশনালি পাবলিশ করা বা কন্ট্রিবিউশনটা আমরা কতটুক মানে শো করতে পারি। এক্ষেত্রে কি মিডিয়েটর বা মডারেটর অ্যাড করলে কি কন্ট্রিবিউশনটা কি বাড়ে? সেক্ষেত্রে আপনার একটু সাজেশন চাচ্ছিলাম। আর মিডিয়েশন স্টাডির সময় আপনি যখন করবেন, সেক্ষেত্রে আমাদের বিফোর মিডিয়েশন এন্ড আফটার মিডিয়েশন কিভাবে ইম্প্যাক্ট করে এভাবে একটু দেখালে একটু ভালো হয়।
So is it that if I do not test the mediation, it will have low contribution, and there is a risk not to be, I mean, there is a risk of rejection from international journals if there is low contribution? Or is it that if I have more mediation, more moderator, the contribution will be very high, there is a good chance of acceptance? Okay, the answer is it is difficult to say, because the contribution depends on how much gap in the literature, I mean how much gap you have successfully identified from the literature, and how successfully you have, I mean, filled up the gap in the literature. So if you found out that, yeah, there is no research in the literature, they have tested the mediation so far, and it is important, you found this mediation important, so then definitely this mediation will be an attractive, contribution for to the literature. So again, the moderation is same. The point is, you have to identify whether is it a contribution. Okay, if it has a crucial contribution, the research is very novel and important. Sometimes we make a very unnecessary research. Okay, we conduct very unnecessary research. We put mediation and moderation, but it is not very important. So in that case, the editor may reject the paper. So it depends on the, is there any gap in the literature or not? So here our idea is, the drawing doesn't necessarily lead me to present all the results. That's the idea. It depends on the objectives of my paper or objectives of my thesis. If I have an objective to test mediation, then I will report the mediation. Otherwise, it is not necessary. For example, in their paper, it is apparently seems that yes, there is a mediation, but they haven't tested the mediation. Interestingly, okay, they haven't tested. So you may find this kind of scenario in good journals also. Okay, so the drawing seems moderation or mediation, but they haven't developed a hypothesis. It's not part of their objective, so they didn't report about this. Okay, is it clear?
Yes, sir.
Okay, thank you. Oh, now let's move on to the method part. So for the purpose of this study, data were collected from 6 public universities in Peninsula. Okay, let's talk about sampling. Okay, to calculate sample size, we used G power. Okay, with the setting as follows. Okay, number of 3 predictors, power set. Okay, sample size required to test this model was 550. It's a huge sample. Okay, a consistent, they have tested consistent PLS. We are not testing consistent PLS. Okay, so why I have taken this model as a paper, this paper as a model or as a sample, because we want to understand many things from the same papers. It talked about consistent PLS. Consistent PLS is recommended if you test a theoretical model. It means you didn't bring many changes. So in that case, it is recommended that you can use consistent PLS. Sometimes they see the consistent PLS as an alternative of AMOS. SPSS. Okay, so where we came to know that SPSS is recommended for testing theory. Okay, conforming theory or rejecting theories. So it's kind of similar concept. Consistent PLS. But in most of the cases, we are not using consistent PLS. Okay, in our model, cloud computing adoption, we will not use consistent PLS. Okay, that's the understanding you should know. Okay, now let's talk about the sampling. Okay, now how many samples should I have, or the minimum sample should I have? Okay, so testing a model like this. Okay, let's move to our cloud computing. Okay, so we have a model like this: 1, 2, 3, 4 variables and one dependent variable. So who are our populations? Okay, and who are our respondents? So we don't know exactly. We don't have any list of population. We don't have defined number of population. Okay, so in most of the cases, we see such scenario in social sciences. Okay, we face similar problems. It's not a problem actually, it's the reality. Okay, it's the reality. For example, you study consumer behavior. So who are your consumers or customers? So how many customers you have? There is no certain number. So you don't have the defined population set. So in most of the cases, we have this kind of reality. So even if the statisticians, the pure statisticians, they don't accept or they don't try to accept the convenience sampling process or the method. Okay, but in social sciences, it is very common practice to take convenience sampling technique. What is convenient? Means you go conveniently to the respondents. Okay, so statisticians, they always recommend to use random sampling. The random sampling, they like it very much. It's yummy to them. So why they like it? Because it's very touchy, is very interesting, and seems very pure and attractive, this technique, random sampling. So okay, I guess you can the meaning of random sampling. If not, please Google it in later. So right now we talk about the convenience sampling. So going to the respondents conveniently, because we cannot take random sampling because I don't have a list of respondents. Okay, in random sampling we need to have the list of respondents. So in our case, most of the in situations, almost all the situations, we don't have the list of respondents. So we have to use the convenience sampling. That's the idea. Now, what is the minimum sample requirement to study this model. Okay, what is the minimum sample? Now we have two different understanding about the minimum sample. One is, if my objective is to draw the conclusion that should be representative. I mean, one is representative sampling, another is, just to test the model. Objective is to test the model. So another one is to generalize my result. Okay, another objective is to generalize my result. Okay, if the result is like this, can it be generalized for all the population or for the industry? Okay, so if the objective is to generalize my result, then I should adopt a different sampling technique. Okay, for generalization purpose. So this technique is called this traditional sampling calculation process. We have a table, sampling calculation table, Crazy-Morgan table. You might have heard about this table, right? Crazy-Morgan table. Okay, let me show you from the Google. Sample size determination model. Can you please can you see my screen? Sample size determination using Crazy-Morgan table. Okay, so it is our traditional method to identify minimum sample. Okay, if for a population. Okay, for example, if the population is number of population is 10, in that case I have to select 10 samples to generalize my study. Okay, if the population number is 220, my sample should be 140 minimum sample. If population size is 1200, my sample size should be 291. Okay, for example, if population is more than a kind of 1 million, my sample should be 384. Not too much, right? 384. So there's the traditional way of calculating the minimum sample size, and they have given the formula here, how they have calculated the minimum sample. Okay, so that's the traditional way to calculate minimum sample size if my objective is to generalize the result. Okay, but in most of the cases we cannot generalize. In most of the cases we cannot generalize because we have we don't know how many population I have. You understand? We don't know how many population I have. So we have to use different technique to identify the minimum sample size. So this
sir, I have a question, sir.
Okay, please.
Sir, is there have any special techniques to identify the sample size for SPSS, AMOS, or SmartPLS? Because in our previous class study, we learned that you can run the SmartPLS with a small sample size. So, এটার জন্য কোনো SmartPLS এর জন্য কি এমন কোনো ব্যারিয়ার আছে যে এর নিচে হবে না? Is there have any barrier এ ধরনের বা কোনো সিলিং আছে কিনা?
Okay, thank you. So we have a question here. So what is the minimum sample size requirement for the software to run? Okay, For example, we have SmartPLS software. So what is the minimum sample size is required for the software, not for the model, for the software to run? And what is the minimum sample size required for the AMOS, another software, to run? So that's the question. Okay, the answer is we do not bother about the software, rather we are concerned about the model. So the question is, what is the minimum requirement to test the model? Okay, so this is our concern. So the answer should be given by G power. So as I said, we can use table, okay, traditional table, if my objective is to represent the population, or if I want to generalize my result. Okay, but in most of the cases we cannot generalize because we don't know how many population I have. So that's the problem. So in that case, most of the cases we see we are testing a model. Okay, we are testing a model and we identify the minimum sample size requirement for the model. So to identify the minimum sample size, now the very recent literature, it suggests to use the G power software. Is a software to identify the minimum sample size. I have given a folder and I have given instruction as well to install the G power software. Now let me take you to the G power software. This is the interface of the G power. So they have given in their paper about the configuration. Okay, what is the configuration they have used? So in our case, we need to bring some changes. By default, test family is related to the t-test, and we have to come to the f-test. Okay, f-test. And in statistical test, we have to change linear multiple regression, fixed model, R-square deviation from 0, this one. And this configuration will give you this thing, the a priori compute required sample size, given alpha, power, and effect size. Okay, means we want to compute the required sample size, the minimum required sample size. We have given alpha, we have given power, and we have given effect size. Based on this, they will calculate the minimum sample size. Okay, now the effect, talk about the effect. So if you move the cursor, okay, it shows three different effect size: small, medium, large. So let's let's select the medium. Okay, 1.5. Okay, it's okay, keep it default. Okay, then alpha, okay, no change because 95% in confidence level, alpha is 0.05. Okay, power is not confidence level actually, is you can change the power. We have low power, we have high power. Okay, so you can learn more about the power from the literature. So right now we can even keep it by default, or you can, they have put 80% power. Okay, so no problem, you can switch from 80, 70 to 90. So high power. Number of predictors. Okay, here predictors means how many arrows are pointed to a particular endogenous construct. That's the idea of predictor. Okay, for example, in our case, okay, let's see, cloud computing. Okay, let's see this one. How to identify the predictors, number of predictors. Okay, the answer is how many arrows, 1, 2, 3, 4, are pointed to a particular endogenous construct, I mean the dependent construct. Okay, the maximum number of arrows pointed to a dependent construct. We see 1, 2, 3, 4. Here the number of predictors should be 4. Okay, now imagine that cloud computing, okay, it become the formative construct. Cloud computing becomes the formative construct. Now it is reflective. You have question? Okay, sorry. Cloud computing is now reflective, and imagine it become part of our formative. If it is formative, then arrows will be pointed to the cloud computing adoption, right? It will directed from items to construct. So in that case, the number of predictors will be changed. The maximum number of predictors. For example, here we have 1, 2, 3, 4, 5, 6, 7. The number of predictors would be 7 if it is formative construct. But now it is reflective, and we see only 4 arrows coming to a particular DB. I mean the dependent variable, dependent construct or endogenous construct. Okay, so that's the idea behind identifying the number of predictors. Any question regarding predictors? Okay, I get it is easy. Now we have.
I have one thing. I think number of predictor is like number of hypotheses. Is it okay?
Might not be, because sometimes you have a moderation, for example. Okay, you have a moderation here. This relationship. Okay, so means moderation is pointed to here. Okay, so in that case you have another more hypothesis, but the arrow remains same.
Understand.
Yeah. And also the mediation, for example, you have mediation, you have hypothesis for mediation, but the arrows didn't change. Okay, so the predictors, we have the 4 predictors, right? 1, 2, 3, 4, 4. So we have given 4, and power we used 80. Okay, similar to their calculations. Let's see. We have only 85. Minimum sample size 85. Okay, let's bring some changes here to see whether sample size increases or decreases. Like okay, 95 power.
We are not seeing the G power screen.
Sorry.
G power.
Oh, sorry. G power screen. Okay. Okay. So now I want to test. I have to calculate the minimum sample size. Initially, we put 80, okay, and we put 4 in the number of predictors. Now calculate, it gives you 85, 85, okay, means you need 85 samples to study this model, our model. Okay, now if you bring some changes here, like large sample, okay, 0.3, sorry, large effect 0.35, let's see, 0.35. Now calculate. Oh, it even reduced the sample size. Okay, if it is only small 0.02, then calculate. Oh, it gives you 602 sample. Okay, so the idea is, in the literature you have given a suggestion to use small, medium and large. So simply you can manipulate the sample size, okay, from G power, no problem. So you just refer to the G power that, yeah, based on this configuration, I have calculated my sample size and it gives me 85. Okay, now
we conclude that if we select the small effect size, then our sample size will be the higher. If we select the medium, the sample size would be the less than proportionately less than the small size or small effect, like that.
Yes, yes, yeah, we can we can manipulate and we can conclude, but it is my understanding, right? I should not write in the paper, okay, because they have used the small samples, effect size to show more sample size. Why? They have used a consistent PLS, and consistent PLS is related to testing the or rejecting a kind of models like we see normally used in AMOS. And in AMOS, most cases you have to use large sample size in AMOS to fit your data with the fit indices of the software. So they also use the PLS as an alternative to AMOS. So that's why they have to use the large sample size, and to show large sample size, they have manipulated is small. And they didn't provide any justification. You see why they have used, why they didn't use the medium or high sample size. So better you can put a reference of Cohen, okay, here, which they didn't.
I think large sample size will increase the generalizability of the results.
Yeah, sure. Large
That may be the reason.
Yeah. This is one understanding. The more sample I have, the more I have the generalizability. When a chance of generalize, or the confidence I have to generalize the result. So, but again, to generalize is very challenging because your sample should be representative. But if you collect more sample from your nearby, okay, conveniently, for example, so the question may be, is it representative to generalize, right? So it kind of risky job, or try kind of difficult task. So better if you have a representative samples, okay, and more samples, then you can generalize your result. So far, idea is we have used the G power to identify the minimum sample size requirement to test the model.
G powerটা কি আমরা তখনই ব্যবহার করব যখন আমাদের কাছে কোনো পপুলেশন লিস্ট যখন থাকে না তখন?
Yes, because in most of the cases we don't have the list of populations. So in that case, our objective is what is the minimum sample requirement to test the model. So in this scenario, it is highly recommended to use the G power to identify the minimum sample size. Okay. Now, okay, let's move on. They say the sample size required to test this model was 350. Okay. In
Sir,
our
one more asking, sir, power set at 80%. What does it mean, sir? Power set
so
80%
right.
or 90%?
Okay, it is another kind of is a kind of confidence I have on the data. Okay, is a kind of confidence how much power I have. So again, this definition is given purely by Mr. Cohen. Okay, so most of the cases you see that everybody refer to Mr. Cohen's paper, and also this G power software has been designed based on his recommendations. So the primary understanding is a kind of my confidence about my data. Okay, so we have
That is the author's own confidence level towards his data.
right. It is my confidence. Yeah. So again, he has also suggestion, okay, in his book to even you can switch to 80%, 90%, 95%. By default, it was 95. So we have changed it to 80 because we have seen this paper. I mean, our sample paper, they have used 80%. Okay, so you just simply put references. Okay, it's enough. Okay, so let's move on. Then in our case, we have identified the minimum sample, and now let's see how many sample we have. Okay, we want to test the model, the cloud computing adoption. I just opened the Excel file. Okay, cloud computing adoption. So we see okay many items. Now open our SmartPLS. So now we want to create a new project. SmartPLS software, open the SmartPLS software, create a new project. Okay, cloud computing adoption. Okay, cloud computing adoption. Double click, input the data from the computer. Okay, it gives you the description. From the description, just take a look whether is there any problem. And we see yes, there is a problem in maximum, right? We have 55 here, and only this, only based on one, just one or two maybe, right? You see the effect in standard deviation, right? It increased the standard deviation more than 5. So whereas other standard deviation is below 1. So there's a problem in the data. So we need to check in our Excel. Okay, so in the Excel, as I said before, importing in the SmartPLS, we need to have a data screening process. But based on, we need to check, is there any major problem in that data? Right now, we want to identify, is there any maximum values, okay, typing error sometimes, or any other error, for example, a straight liner. You know, we have straight liner and we have outliers. So straight liner, it means they didn't actually read the questionnaire. I mean, the respondent, they didn't read the questionnaire. They simply, you know, check. I mean, the tick. I mean, very quickly. Sometimes they tick straight away, means everything 4, 4, 4, 4, 4, or everything 2, 2, 2, 2, 2, right? So we can understand that the respondent didn't read my questionnaire properly. Okay, so this kind of problem is called a straight liner. So in data screening, we can easily identify straight liner, as well as we can easily identify outliers. Outliers mean sometimes they speak, you know, something which is not true, which is not real. Okay, is unreal. Okay, not real. Okay, is unreal. So we need to identify this sort of, you know, practice also. Now, question is how to identify. You know, Excel formula, start with the equal sign. Okay, equal. Then max. First, we want to identify the outliers. Is there any unreal or any typing error, for example? Max. Maximum. Okay, then double click. So it is asking for the range. Okay, then click on the first cell, then try to press button shift, control, and the left arrow key all together at the same time. Shift, control, left arrow key. So it will take you in the first cell or the first column. Then in the function box, you just complete the parenthesis by putting the first bracket. Then enter. So it gives you the maximum number in this row. Okay, so maximum 6. So now you move the cursor until it becomes plus sign. Okay, then double click. So it automatically calculate for all the data. Okay, now we see, yes, there are problems, maximum numbers. So now how to easily identify the maximum? Simply sorting, by simply sorting largest to smallest. Okay, expand the selection. Okay, now we easily figure out that there are two maximum amount we have in the data. One is 55 and another is 44. Let's check it out where it is. Oh, in the first column. One is 55 and another is 44. So we can understand that it is a kind of, you know, misrepresentation, because this number actually represented the data. I mean, if we come to the exercise, okay, complexity, we ask 5 questions. And we have collected the data using the Likert scale. Likert scale, scale having 1 to 5 number. Okay, 1 representing the okay, disagree, okay, and 5 maybe highly agreement, okay, disagreement, okay, this kind of thing. So imagine we have a scale like, okay, let me take you a scale. It will be very easy to understand for the beginners, I guess. Okay, you know, we have given you this, I mean, we have presented earlier about the model. So here they have used a scale, right? Strongly disagree and strongly agree. Okay, it's an attitude scale. Okay, now 1 representing strongly disagree and 5 representing strongly agree. So now come to the Excel. So here you see the maximum should be 5 and minimum should be 1. So that's the number I should be between, I mean, in our Excel file. Okay, the number should be between 1 to 5. But here we see it is 55 and 44. So definitely is a kind of, you know, typo error. Okay, it's a kind of typo error. We need to, you know, correct this one. 5, that should be 4. Okay, so now we have solved the problem. The first one, it talked about, okay, maximum. So now you can simply delete this one, no problem. We do not need it anymore. So next one, we want to see, is there any straight liner? Straight liner means the respondents rate every question straight away, 2, 2, 2, 3, 3, 3, right? So how can we identify the straight liner by using Excel? Okay, so it's very easy. Simply put equal and find the standard deviation, STDEV. Okay, STDEV. Okay, standard deviation. Okay, let's use this one. This function is available comparable, okay, and earlier, okay, okay. Calculate standard deviation with entire population, logical values text, okay. This one, let's see. First one, standard deviation, okay. So we have calculated the standard deviation, and we have double click, calculated all the standard deviation. Now, if it is straight away, standard deviation would be 0, right? Let's see, is there any 0? Sorting smallest to largest and expand the selection, of course. Yes, we have found 1 0 standard deviation. You see, the respondent, he puts all, I mean, the question 4, 4, 4, 4, 4, 4, 4. You see? So this is the problem. He didn't, he or she didn't read my questionnaire. So in that case, we can think about deleting this case. Simply delete, because it's a problem. It should not be like this. Okay, so we have deleted one response from the data. Now save it. Sorry, Save. Okay. So you can rename it, or you can save it as okay. Okay, double click. Cloud computing adoption. This is part of our dependent variable, right? Let's see what is the model. Okay, there's the model: complexity, relative advantage, stock management support, right? There's the model. Now we want to design this model in SmartPLS. Okay. So now complexity, relative advantage, complexity. And we will rename this one. Relative advantage. Top management support. Perceived risk. Sorry. Adoption. Okay, right. Bottom. Okay, connector. Okay, connected. Now let's go to the paper. Okay. See, after analysis and result, okay, let's see what they said. As suggested by Hare et al. 2017 and Chin et al., we assess the multivariate skewness and kurtosis using the software available. Okay, the results showed that the data we have collected was not multivariate normal. So the idea behind this, presentation. So even if they have presented the skewness and kurtosis, and they have said the Hare suggested, okay, so it's not necessary actually. Even Mr. Hare in his recent papers, so many papers, he didn't present this skewness and kurtosis, because we have already taken the PLS SEM as a non-parametric, okay, non-parametric standard, meaning we do not have any assumption about the data distribution. So once we have taken this standard, so we should not report this kind of thing. Okay. Now, if you are forced, sometimes, maybe, unfortunately, your examiner is forcing you to report this kind of thing, okay, about the normality of your data. So in that case, you cannot use SPSS, you cannot use even PLS, okay, because SPSS cannot give you the multivariate normality, okay, multivariate normality, multivariate skewness kurtosis, okay. So in that case, you have to use this software, okay, web power, okay, the online software, web power software, to identify your skewness and kurtosis, okay. So here we are not using this, okay, that's the understanding, because our assumption is non-parametric, we don't have assumption about the data. Okay, next, to analyze the research model, we use the partial least square technique using SmartPLS 3, okay, following the recommended two-stage analytical procedure by Anderson and Garbin. We tested the measurement model followed by an examination of the structural model, okay. At first we have to test measurement model, okay. Now come to the measurement model, okay. In the measurement model, we see they said to assess the measurement model, two types of validity were being examined for us: the convergent validity and then the discriminant validity, okay. So what is convergent validity? Okay, in convergent validity we have many indicators, okay. So basically we have to identify loadings, reliability, and AVE, okay, for reflective measurement model, not formative measurement model, okay. If the measurement model is reflective, okay, we have to identify these things, okay. Then discriminant validity, okay. So first we have to identify the load. I mean, we are going to replicate this table, okay. Construct items loading from back. So now I open the Excel. We want to find out the loadings. We talk about the relationship between items and construct. We have a value, and the value is loadings. So how do we get this? Now calculate PLS algorithm. PLS. Okay, let's take to my PLS software. Okay, now we are calculating the loadings, CR, AVE, all these things. Algorithm. Okay, simply start calculations. So we have in the report outer loadings. Click on outer loadings and see any red marks. Red marks indicates the loading is below the recommended threshold. Okay, now what is the recommended threshold? I have given you a paper. Okay, the paper is under the PLS paper. In the folder PLS papers, there is a title, when to use and how to report the result. Okay, this paper, when to use and how to report the result of PLS papers. So this paper is developed by PLS gurus. All the gurus are here. Joseph here, okay, Marco, Ringel. I know Ringel is the founder of SmartPLS software. And Joseph here is a very popular guy in multivariate data analysis. Okay. Okay. Now, how can we understand the minimum threshold? So, this paper, if you read, I highly suggest you to read the paper. So it's very recent paper. Okay, very recent paper. They published in 2018 November. Okay, December accepted. Okay, so means it came in the early 2019. So still their recommendations and their suggestions are used by authors around the world. So better to use their recent suggestions. So talked about the sample size. They have given suggestion here. Okay, you can read their suggestion: distributive assumption, secondary data, then statistical power analysis, goodness of fit. We talk about goodness of fit also. Evaluate partial least square structural equation modeling. And now assessing reflective measurement model. How can we assess the reflective measurement model? Okay, this is what we are looking for right now. So they have also suggested for formative measurement model. And at last, they have summarized it in a table. Yeah, here. We are looking for this table at page 15. Reflective measurement model. What should we have actually? Yeah? So the loadings should be higher than 0.708. That's the suggestion. Loading should be higher, should be greater than 0.708. Okay. So now let's see what is our loadings. We have few loadings which are red marks that are lower than 0.708. So here all loadings are higher than their recommended threshold. Now come to the figure. Okay, let's share my screen, software screen. So we see some loadings are below the standard. Okay, for example, this one is below the standard, I mean 0.708. So we need to check the AVE. AVE. Inner model. Okay, sorry, construct, right? Construct AVE. Okay, AVE also. So now the idea is if the AVE is more than 5 and some items it above 0.5 but below the recommended threshold, we can retain this item. Okay, there's a suggestion given in their paper, but ideally all loadings should be 0.708 ideally, but exceptionally we can retain some items if my loadings is higher than 0.5 and item loading is 0.5 as well. Okay, but below the recommended threshold, no problem. So it fall in this exceptional category. Okay, 0.663. So we can justify that my AVE is more than 0.5, so we retain this item. So our objective is try to retain all the items, because deleting one item may have adverse effect on the validity, right? So better we justify. If we have a scope, if we have a room to justify, then we should not delete. Okay. This one, you see, it is below the, even if AV is more than 0.5, but items loading is less than 0.5. So we have to delete this item straight away. Okay. Okay, now we rerun again. Okay. After rerunning, we see now the AVE, is much better, and all items are more than standard threshold. Okay. Here also we have another problem. 4. Okay. So even if AV is higher, but this one is below the 0.5, we have to delete this one as well. So then rerun, check any further problem. This is okay, more than 5. Okay, close to 0, 6. Okay, we retain no problem, and here all the loadings are good. Okay, so this is the first initial screening. Okay, we have checked the loadings, AVE. Okay, and okay, these are the 2 things so far. So now we want to. Okay, question.
হচ্ছে যে ভেরিয়েবল থেকে আমাদের যে কমপ্লেক্সিটির মধ্যে এবং ক্লাউড কম্পিউটিংয়ের মধ্যে যে পয়েন্টস গুলো দেখছি আমরা 0.448 0.280 এগুলো তো কম মনে হচ্ছে কিন্তু বুঝতেছেন
This one.
জি জি জি
Okay, right. This is the path coefficient. Okay, path coefficient. Okay, we are not concerned about this figure right now.
এটা স্ট্রাকচারাল মডেলের অংশ
Right, it's part of structural. So before a structural, going into structural model, we have to measure the measurement model first. We have to establish. The idea is we have to establish the measurement model first. So in the steps of establishing measurement model, the first criteria is to identify their loadings, whether loadings are as per the standard. Is there any low loadings? Low loadings need to be deleted. Okay, that's the idea. So we have already deleted 2 items. Okay.
Sir, can I have a question? If most of the items, the value of most of the items are below the 2 threshold that you have just mentioned, then under this circumstance, what can we do actually?
So the idea is the loadings, all the loadings are less than 0.7, for example. Okay, and here less than 0.7 but more than 0.5. Okay, that's the, I guess you have this question. More than 0.5 and less than 0.7. So in that case, we will see whether the AVE is more than 0.5 or not. So if it is more than 0.5, okay, we'll retain all the items. This is one scenario. Okay, another scenario, it is very worst case scenario, that we have all the loadings are below 0.7. Okay, and also here the AVE is less than 0.5. Is worst case scenario. Okay, so for example, these are 0.4, 0.3, right? So AVE is also less than 0.5. So in that case, we have to think about that maybe we have problem in my data or in the framework. Okay, maybe our respondents they didn't understand the questionnaire. So you have to collect the data again. This is worst case scenario. You have to revise the questionnaire, wording, language, and then go for collecting data again. You understand?
Yes, sir.
Okay, thank you. This is worst case scenario. Okay. Sometimes we go to the respondents, but we don't see, we don't feel that questionnaire, whether questionnaire fit with this respondent or not. They understand easily or not. We go with the the very technical terms that is used in the questionnaire. We didn't feel that questionnaire need to be translated into the local language. Sometimes it is very necessary to translate the language so that respondents can easily understand my questions. So in that case, if the question is very easy and not so many questions, sometimes if the respondent see you have so many questions, like more than 200 questions, okay, you approach to the respondents. So respondents will not read all the questions. Okay, it is very, you have to understand the reality also. So as a researcher, you have to be responsible for everything of your research, so including the design of the questionnaire. Okay, so if you see the questionnaire is becoming very long, lengthy, so you have to reduce the length of the questionnaire, because if the respondent do not respond properly, the data will not be reliable. Okay, that's the understanding. Okay, now
question ছিল,
okay,
সেটা হচ্ছে আমি ফেস করছি, বিষয়টা হচ্ছে আমার ভেরিয়েবল যে পাঁচটাই আছে, পাঁচটা মানে ধরেন আমি রিফ্লেক্টিভ করলাম, এট দ্যাট টাইম আমার ভেরিয়েবলের কনস্ট্রাক্টের এবি লোডিং দেখার পর আমি দেখতেছি লোডিং গুলো আমার 0.5 এর উপরে আছে, আবার 0.7 এর নিচেও আছে, 7 এর উপরেও আছে লোডিংসটা। আর এবি পাঁচটা ভেরিয়েবলের দেখতেছি আমি 0.5 এর নিচে, 0.4 এর উপরে। তো ওই সময়ে আমি যদি কোনো আইটেম ডিলিট করি, তখন ধরেন একটা 7টা ভেরিয়েবল আছে, 2টা আইটেম আছে, 2টা যদি আমি ডিলিট করি, আমার এবি 0.5 এর উপরে যাচ্ছে, আমার লোডিংও কাছাকাছি যাচ্ছে। কিন্তু আমার প্রবলেমটা হচ্ছে আমার 5টা কনস্ট্রাক্টের এবি কম, মানে 0.5 এর নিচে, 0.4 এর উপরে। তখন আমি কয়টা আইটেম ডিলিট করতে পারবো?
Okay, there's a situation sometimes we face after collecting data. Okay, so the idea is maximum 20%. There's a suggestion that maximum 20% items we can delete.
ওটা কি ভাইয়া শুধু একটা কনস্ট্রাক্টের জন্য 20 আইটেমস নাকি টোটাল?
In a total, from the total. So if you have such problem, so maybe we need to check whether the question's wording was correct or not. Wording, আমরা যে ল্যাঙ্গুয়েজে প্রশ্নটা ডেভেলপ করি, ওই ল্যাঙ্গুয়েজ ঠিক আছে কিনা।
আমি ভাইয়া বাংলায় করছি কোয়েশ্চেন, ইংলিশেও করছি, দুইটাই মানে ট্রান্সলেট করে বাংলা সহ রাখছিলাম। তো সেক্ষেত্রে আমার ডাটা কালেকশন হয়েছিল 262। তো আমি ওটার ডাটা স্ক্রিনিং করে পরে মানে সবকিছু ঠিকঠাক করে সিএসবি তে আনার পর ওটা 258 এর মতো হয়। হওয়ার পরে আমি যখন এটা রান করি, দ্যাট টাইম আমি দেখি কি আমার প্রথমে আমি লোডিংসটা বের করি, লোডিংস বের করার পর দেখি কি আমার 0.5 এর নিচে থাকে না, কিন্তু আবার 0.7 এর নিচেও আছে। আবার এদিকে এবি দেখি কি প্রত্যেকটা মানে 5টা কোনোটাই 0.5 এর উপরে নেই, মানে আমার ডিপেন্ডেন্ট ইন্ডিপেন্ডেন্ট সবগুলোই দেখি কি 0.4 এর উপরে, আবার ওইদিকে 0.5 এর নিচে। তখন আমি যখন আইটেম ডিলিট করি, 2টা বা 3টা এভাবে ডিলিট করা শুরু করলে, তখন আমার এবি 0.5 এর উপরে যায়। 0.5 এর উপরে যাওয়ার পরে দেখি কি আমার আবার যখন আমি কনভেক্ট আলফা করি বা মানে রো যেটা ওটা বের হয়, ওখানে দেখি কিছু রেড মার্ক হয়ে যায়, আবার কিছু গ্রিন কালার থাকে। তো আমার মানে কোয়েশ্চেনটা ছিল যে আমি আইটেমস যদি ডিলিট করি তাহলে 20% যেটা ওটাকে আমি একটা ভেরিয়েবলের জন্য নাকি 5টা ভেরিয়েবলের জন্য কমপ্লিটলি 20% ডিলিট করব, আর যখন আমার এরকম এবি ভালো হচ্ছে, লোডিং ভালো হচ্ছে, বাট আমার কনভার্ট আলফা বা রো যা আছে ওগুলো যদি মিক্স হয়ে যায়, তো মানে কিছু রেড কিছু গ্রিন হয়ে যায়, তো সেক্ষেত্রে কি আমার অ্যানালাইসিসে কি কোনো প্রবলেম হবে বা আমার এই মডেলটা?
Okay. I think I got the idea. So basically there are many questions here. If I summarize, number one is how many items I can delete, okay, from the construct. So even if there is a 20% rule, okay, so for example I have deleted all the 3 items, okay, from this construct, but I remain under this rule, okay, I abide by this rule, okay. I haven't deleted more than 20%. So the idea is I have deleted all the items from the same construct, so there is no item of this construct. So what is the meaning of this construct, right? So it's meaningless. So this is not a valid construct right now because I have deleted items. You understand? So even if software suggests something, but as a researcher, we are human being, we have to evaluate it subjectively. Always, whether the suggestion given by the software should be taken, should be followed or not. So as a researcher, we have to understand the item you are deleting, are they important or not? If you see these are important, then you have to retain it, and maybe you have to think about forming a formative construct. If you see that all items are important to form the construct, to make the construct, so and you have to retain all the items, so then think about designing formatively, so you have a chance. Okay, you can discuss that, yeah, reflectively, okay, my loadings was very inconsistent, okay, but these questions are very important, okay, to validate the construct, so I have to retain, so I design formatively. Okay, this is one justification you can put. So that's the idea. Okay, come to the next question. So I have reliability problems. So there are 3 indicators of reliability. Okay, how can I report? Okay, I guess we will discuss it inshallah after calculating our model also. Okay, we are coming to this question later on. So okay, so far that's the idea. Okay, now I move on to the Excel sheet where we are replicating the table 1, I mean the convergent validity. So here the construct, then items, then loadings, then we have CR, then we have Cronbach alpha. So maybe we can think about the let's see the report of reliability, construct reliability, quality criteria. Under the quality criteria, construct reliability, we have Cronbach alpha first, row, composite, reliability, and AB last. Okay, we simply copy the Excel. Okay, then come to the Excel. Okay, just construct. Okay. Not here. Okay, there. Okay. So construct, and here. Okay. Okay, now put loadings and items. So now from here we can get the loadings. Final result. Okay, let me take you to my PLS. Okay, loadings. From where we get the loadings? Final result. Here it is outer loadings. Okay. Copy Excel. Then come to the. Okay, put it here. Okay. So now this is okay. First this two. Copy these two items loadings. Okay. Now first one is part of cloud computing. Drag it. This one is part of complexity. Drag it. This one is part of perceived risk. Drag it. Then relative advantage. Drag it. Top management support. Okay. So again, we have to drag it down. Okay. This one. Okay. So we get the table. It's called the convergent validity table. Okay. You can put it in the Word file. Okay, no problem. You can copy the table and put it in the Word file and revise it. I mean, the shape your table as per the APS style, right? No problem. So now come to the explanation. Okay. First, what is convergent validity? Okay. What is the convergent validity? Convergent validity, how much converts items with the construct? Means how much close the item with the construct. Okay, this is called convergent validity, and it indicated by the loadings. So these loadings are basically the correlations. Okay, the values of correlations. Those loadings are basically the correlations between items and the variable. Okay, so now it indicates. Okay, so the convergent validity establish the coherence between items, closeness between items and the constructs. So that's the idea of convergent validity, and we see that our values, so loadings are most of the loadings are above the recommended threshold. Okay, we'll report like this. And the reliability. Now we have a question that there are three types of reliability. One is Cronbach alpha, rho A, composite reliability. Okay, basically these three talk about the same thing, reliability of the scale. Okay, it talk about the reliability of the scale. And what is reliability? Okay, reliability means, so we have many questions and we have one variable. Okay, so now how much consistent my scale is, okay, that is indicated by the reliability. How much consistent? Consistent means if I go one respondent, okay, the way he behaved with these scales, with all the questionnaire of this construct, the way he treated my questions, okay, should not be much different from other respondents. That's the idea. Should not be different, much different from other respondents. Means all the respondents, they have treated this scale in a similar fashion. Okay, that's the idea of reliability. So if the respondents treat the same scale differently, there is a huge difference. Then we think about, we say there is a problem with the reliability. Okay, so now statistically we can identify the reliability issue by three indicators, by three methods. One is Cronbach alpha, another is composite reliability, another is rho A. Okay, now we may have a problem with rho A, for example. So rho A is below, say for example, this is 0.5. Okay, for example, so we have Cronbach alpha more than 0.9, composite reliability more than 0.9. So we have rho A less than recommended value. So now what should we do? So you simply delete this one. Okay, so you report that using Cronbach alpha and composite reliability, my scale has been established as a reliable. Okay, that's the idea. So you should not report the rho A if you find that you have already passed based on two criteria. No need to go for the third criteria. So even in some papers, recent papers, they have criticized Cronbach alpha values. They said goodbye Cronbach alpha. They have published a paper titled like this, goodbye Cronbach alpha. So they try to focus on CR, composite reliability. Okay, they said composite reliability is much reliable indicators. So okay, you can remove Cronbach alpha as well if you wish, but for PLS, it is highly suggested you report CR, I mean composite reliability. Okay, so in our case, we see the value is more than recommended threshold. Now, what is the recommended threshold, right? That's the question. So again, come to the paper, when to use and how to report. Okay, here you see Cronbach alpha is lower bound. The composite reliability is the upper bound. For internal consistency, p value usually lies between the bound. Okay, minimum 6. Okay, reliability minimum 6. Okay, if it is in exploratory research, recommended 0.7. Okay, maximum 0.95 to avoid indicator redundancy. Okay, means we have a maximum threshold also. It should be maximum 0.95. If it is more than 0.95, then there is a problem with redundancy. Okay. Okay, recommended between 0.7 to 0.9. Okay. So that's the idea, okay, we got from the paper about the reliability. So in our case, we see that our values are more than 7 and less than 0.95, right? We have 1.938. Okay. So no problem. We don't have any redundancy problem, as well as we don't have any lack of reliability. Okay. So we passed the criteria. Now AVE, average variance extracted. So average variance extracted. Talk about AVE. So AVE should be greater than 0.5. Okay, for conceptually similar construct, there should be okay, sorry, this is another one, discriminant validity. Okay, now AVE should be greater than 0.5. Okay, in our case, we have passed this criteria, right? Our AVE is all more than 0.5. So come to the paper. I mean, we tried to replicate.
AVE মূলত কি ইন্ডিকেট করে?
Average variance extracted, meaning how much variance my items, existing items, can explain. So minimum, 50% variance should it has the capacity. It should have the capacity to explain minimum 50% variance. So if more, then it is better. Sorry.
আর আমার একটা সিচুয়েশন আপনার সাথে একটু শেয়ার করতে যাচ্ছিলাম অ্যানালাইসিস এর ক্ষেত্রে। স্যার আমি কি করব এখন?
Sure.
আচ্ছা, তো আমার একটা সিচুয়েশন ছিল কিছুদিন আগে SmartPLS এর একটা কাজে আমার ওখানে আমার আলফার ভ্যালু 5টা ভেরিয়েবলের মধ্যে আলফার ভ্যালু দুইটাতে আসছে 0.6762, বাট সিআর ভ্যালু অ্যাবাভ 0.70।
ওকে,
তো ইন দ্যাট কেস আমি কি করতে পারি? যেহেতু আপনি একটা রেফারেন্স দিয়েছেন যে আলফা অনেক সময় কারেন্ট ইয়ারা এটাকে মানে গুড বাই বলছে না, কিন্তু দেখা যাচ্ছে ট্রেডিশনালি যারা রিভিউয়ার থাকে বা আমাদের দেশে এখন বা অনেক সময় চায় বা দুইটা বোথ আলফা এন্ড সিআর রাখার ইয়াটা আছে। তো সেক্ষেত্রে আমি আসলে 0.67 বা 0.62 যে আলফা, এটার কোনো রেফারেন্স আছে কিনা, আমি এটা মানে রাখতে পারবো, এরকম কোনো রেফারেন্স আছে কিনা? আদার আমাকে কি এটা বাড়ানোর জন্য আমি কি করতে পারি আমার ডাটাতে?
Okay, the question is my alpha shows low, but my CR shows high. So the same thing they talk about in the paper. So alpha is lower bound and CR is upper bound, means CR should always be high. And so you report CR first. Okay, you say, okay, my data passed the criteria of CR. So then try to justify the alpha that even if it is 0.6, but we are exploring, okay, the new phenomena. So in exploratory research, so we want to see the new variable, or we have used the new variable, new items in a different context. So in that case, it is also suggested to use minimum threshold 0.6, okay, as a standard. So you can justify like this.
আমার এটা কিন্তু কনফার্মেটরি না, এক্সপ্লোরেটরি টাইপস।
Yeah. So you have more ground to justify.